Hey guys, welcome to lesson 4.7. Today we're going to focus on similarity statements, and this is just basically a very formal way to describe similarity between two figures, or just a way to state that two things are similar. Okay, and now similarity can come of pretty much all of the transformations we've talked about, but we're going to be focusing really on the fact that dilations create similar figures. It's also very important to remember that when you have similar figures, their angles are preserved, meaning they have the same angle still, and the ratios of the side lengths, meaning the ratios we make between corresponding sides, will stay the same. The parallelism of two lines, that's also going to be maintained, but that's just not one that we're focusing on right now. All right, so when we're using symbolism to talk about similarity, this right here, our squiggly line, is what we're going to use to put in our similarity statements. So for example, here's one. Triangle ABC is similar to triangle DEF, right? This symbol right here is similar to portion of that sentence. And what's important about these statements is that the order of the letters really, really matters, because saying that ABC is similar to DEF matches A to D, it matches B to E, and it matches C to F. Okay, those angles have to be equal in terms of their positioning in the statement. All right, so if we were to go ahead and match the sides, like the corresponding pieces of these two triangles, remember what we talked about yesterday, where the biggest sides of the shape are going to go together, and so are the smallest ones. So A and C are going to go together with F and D, right? Because those are both the biggest side on each triangle. B and C, or BC, is going to match with EF. Okay, and then AB is going to match with DE. All right, so now that we've matched the corresponding sides, we can see that the vertex at A is between green and blue, and the vertex at D is also between green and blue. Those are matching. They are the same angle, okay? B is between green and red, and so is E, which is why both of them are in the same position, right? They're both in the middle. And then F and C are between blue and red, so those are going to be matching. All right. So again, it's very, very important the order in which you write these letters. So let's do some practice coming up with similarity statements. It always helps to first match the sides. So here we know that the biggest side is 9, and here we know the biggest side is 18. Next, it's always easier for me to do the smallest pair next. So 5 is the smallest in this triangle, 10 is the smallest in this triangle. That leaves us with the middle length. So now that we've done this, we have the first part of a similarity statement, right? SRQ. So they decided to name the first triangle as SRQ. You can really name the first one however you'd like, as long as you match it with the second one. So angle S is over here. It's between blue and green. So the matching one must be T, because T is also between blue and green. So we're going to start with T, and remember I have to put my triangle symbol there too. All right, next comes R. R is between red and blue, so we're going to take our angle that's between red and blue, which is U. And then Q is between red and green. It's also the only angle left, so that has to match with V here, who's also between red and green. All right, and that is my completed similarity statement. This is a V, do not confuse it for a U. All right, let's do the next one. I have some matching sides here. What's interesting about this one is that each of these triangles are actually isosceles, meaning both sides are equal. So it wouldn't be a huge deal if you like switched up which ones you matched it with, because they're equal, right? So 124 goes with the first 9, and the next 24 goes with the second 9. In these situations, you tend to have multiple ways you can write your similarity statement. All right, so now that we've matched our sides, they said RST. So now let's take a look at R. R is between red and blue. It's the one with the arcs they already gave us. So we're going to match that with B here. I'm going to try starting with the triangle symbol. So B, because R matches with B. S is between red and green. So we're going to go R, red and green, and that's D. And then that leaves us with T, which is between green and blue. So we are picking C, which is also between green and blue. Okay, and that is our finished statement. All right, so here we have some triangles, and we want to write some equivalent ratios for the side lengths. Okay, these are similar triangles, so we have ratios existing for every pair of matching sides. So we can start here. We know that AB and DE match. We know that AC and DF match. And we know that BC and EF match. Right? Because these are similar triangles, we know all the ratios are going to be equal. We don't have any numbers, but we just know that this is going to be true if we did have numbers. So it doesn't matter which ratio you start with, and it doesn't really matter which one you put on the top either. Again, I just like to put the bigger one on the top. So we know that ED over AB, that's one ratio. And now I just named the sides with the vertices instead of numbers because we don't have numbers, right? We know that that's going to be equal to, let's do the green one next for fun. We'll say EF over BC. Okay, and my last one is red. We'll call that DF over AC. Notice how I'm putting this line on top of my letters. That's the notation that shows that you're talking about a side length of a shape. It technically means that it's a segment. All right, so those are all the ratios using the side lengths. Because these are similar, they must all be equal. Now we have some angle statements. With angles, they're not ratios because when we're working with angles, we're just literally saying that each like matching angle is equal to the other. So here I would say that angle A, that's the angle symbol, it's not an L. Angle A is equal to angle D because those are in matching positions, and they also have these matching like tick mark things. We can say that angle B is equal to angle E because these are both between blue and green sides, right? And then lastly, we can say that angle C is equal to angle F. Okay, and again, they pretty much told us that in the picture with this markings that they have matching on both of those angles. All right. Moving forward. Now, when you write similarity statements, there are a lot of ways you can actually write them. Because I mentioned briefly before, the way you name the second one depends on how you name the first one. Like this first one has 3 letters in it, DOG. We can organize that in any way we want, right? DOG, OGD, DGO, those are all options, okay? And there's even still more options that aren't mentioned here. But however you do the first one, the second one has to match. So let's start by matching our matching sides, or corresponding sides. We know that 9 is the biggest side on this triangle. Oh gosh, why can't I draw this line? Okay, 9 is the biggest side on this triangle, and 18 is the biggest side on this triangle. So those must match. 5 is the smallest on this triangle. 10 is the smallest on this triangle. So those have to be corresponding. And lastly, we have 8 being the middle length. So it must match with our middle length here, which is 16. All right, so now that we've matched, it'll make it a lot easier to figure out which of these are actually true or valid. So for this one, we named the first triangle DOG. So it went blue-green, green-red, blue, red. So we have to see if cat follows the same format, right? And it would be easier to do this if we like match the angles, right? Blue, green must go with blue, green. D matches with C. O matches with T because those are between red, green. And blue, red, that's the G, matches with my other blue and red, A. So if they went D, O, G, here, 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 but in the second one they said C, A, T. Now the issue is, okay, sure, D matches with C, but O and A, O, A do not match. So this is an issue. This one does not work because O and A don't match. So let's try the next one, D, O, G, C, T, A. So D matches with C, that's good. O matches with T, that's good. And G matches with A. So we're good. This one is valid. All right, number 3, this option, OGD. So OGD and ATC. Does O match with A? O does not match with A, so this one is canceled right away. For this one, DGO. So does D match with C? It does. Does G match with A? It does. And does O match with T? Sure enough, it does. So this is the other one that is valid. All right, for this one we're going to practice just solving for missing sides with setting up a proportional equation. So remember, it's always a good idea to match your sides first. When in doubt, that's always the safe first step. The longest side matches with the longest. So 12 is going to go with X. And 6 is going to go with 9. So we'll set up our ratios and we'll say x over 12. It's fine if you did 12 over x, but just stay consistent. And then 9 over 6. All right, and now we're ready to cross multiply and solve this for x. So we say that 6x equals 9 times 12. Now, 9 times 12 equals 108. And now our last step would be to divide both sides by 6 to get x by itself. So when we do 108 divided by 6, we end up with an answer of 18. All right, we have one more thing to do here, and that is to make some side ratios and then also write a similarity statement. So let's start by matching our sides. This is the biggest there. This is the biggest here. This is the smallest here. So matches with the smallest here. And then these are going to match. All right, so for starters, we can say that R matches with E because they're between blue and green. Q matches with D because they're between red and blue. And then P has to match with C. All right, so that is going to be the finished similarity statement. And to make the ratios, we know that RQ over DE, or ED we should say, is equal to RP. I'm taking this one over this one. It would be over EC. And that's going to be equal to QP over DC. All right, and that is the end of today's lesson. Make sure you can do the practice problems on My Open Math.